Again, with filming the monitor, it's terrible, I know. I can't be bothered making screen capture work. Beautiful moire patterns though, especially if you move in. I did. Maybe they don't record. They were there before I started recording. Logistical troglomaphite. I'm sorry, I should have sounded drunk and southern. Logistical troglomaphite. Finds out Danny Pratt is talking shite again. I'm not going to watch the video, I'm not going to give him the click. I can guess what he's saying. He's sat there with his hood up like an Emperor Palpatine wannabe, saying, "It is completely impossible for this reflection to be so perfect. If the mirror is curved, it cannot be done." Or something like that. He might sound angrier than that. So anyway, I copied that image and I fed it to Google search. Very nice. You just give it the URL and it put the text in by itself. I just put lake. But having been given the URL of the image, it found Lake Matheson. And if you mouse over some of these similar images, yeah, it's pretty obvious they mean Lake Matheson. So, Google Map search. I found Lake Matheson. I've done a distance measurement there. Zoom out. To Mount Cook. Now, what I presume little Danny Pratt is complaining about is that if the Earth is curved, this huge length of lake here, huge length of lake, should be showing the reflection on a curved surface, not a reflection that appears to be on a flat surface. That's a really long lake, that is. That, might take me half an hour to swim that. So how much curvature do you really think you'd see on that lake? On, a world that big? Well, fortunately, we can calculate how much curvature there would be. So if I zoom in here, and then go up to the URL bar, and grab it, grab the latitude, and also find the elevation, which is there, and then go to Reckoner Online and put in the latitude and the elevation and hit calculate. I get numbers. Sea level, ground level 90 meters above it. There's your radius in kilometers. Also available in miles for people who are it's clever. There you go. In miles for people who are afraid of kilometers for some reason. And having done that, you can bring up the calculator. I have a number here. We know that distance. It was, what was it? Didn't know that distance. 725, was it, meters? Divided by 6368128 meters. 6368128 is that many radians. Radians. So it's mucking around with 2 pi, it's just that many radians. Notice this thing at the end here, e minus 4. It's that lot times 10 to the negative 4. Also known as that lot divided by 10,000. If I take the cosine of that, it is 0.99999999352, also known as 1. And minus 1 is times, what was that number again? 6368128. It helps to type 3 in there. 6368128 is, there you go, 0.04127 meters. 41.27 millimeters lower at its far end, mind you, at its far end. And that angle, by the way, if you want that angle in degrees, 725, I think that was it, divided by 6368128 is that number. Put in degrees, not that it makes much difference here. That fraction of a circle, because there are 360 degrees in a circle, that fraction of the radius, sorry, you have to divide by 2 times pi to get a fraction of a circle, because the circle is 2 pi times the radius, then you multiply it by 360 to get an angle in degrees. And it has the same cosine. It's the same angle. Of course, that's the angle at the far end of the lake. If I multiply that by 2, I get the angle to which a thing reflected in the far end of the lake would be tilted. 0.013046 degrees. And I got Mount Cook elevation. That. It's quite a long way above sea level. And then I went to image editing. So here we have a cross section which I have to scroll across to get the whole thing in. This is based on a flat plane sea level, which is the dark blue line here. I put the lake 90 meters above it there, well 9 pixels above it, and I've got a cross section from Google Maps all the way up to Mount Cook right here at the far end. And on top of that, I have drawn the same thing, but with the bottom half, the reflection, rotated through 0.013046 or whatever it was degrees. I'm sorry, can you not see that? Let me just scroll across to the right, where we're looking at the summit of Mount Cook. And apparently have smears on the camera lens. Summit of Mount Cook. Well, the problem is it's so much dark on the screen, it's trying to highlight everything to make it visible. Anyway, the real Mount Cook above, it isn't the proper position because I haven't incorporated the curve, but real Mount Cook above, the reflection below, and that's it with that rotation. Did you see it that time? It moves. It really does. Zoom right in here. And that distance, that's several pixels, you know, it's tens of meters. And back across here to the left. Zoom out so you can see it. I have drawn in, on the next layer, lines of sight. Red lines of sight to visible high points above, and magenta lines of sight down here to their reflections. If I come across here and zoom, that typed plus is somewhere and I don't know where. If I come across here, having clicked the correct window and zoom right in, see, this is where your line of sight to the lowest of those hills, those ridges, disappears into the water, i.e. gets reflected back up. All of this lake out here isn't reflecting a damn thing. And it is the lowest, it is that first one. On the next layer I have a duplicate of the curved with just the lines of sight to the furthest point. Let me just zoom out. Just Mount Cook itself, up there and reflected down there. This purple line back, and then so much easier if I could see what I was doing with the mouse. And here, on this crude drawing, is where your line of sight goes through the lake. Now, notice there's a blank pixel here. That blank pixel is because I did look for some large images. I found a very pretty large image. I'll put that URL of that in the description. And also this large image, which you may note, well, I hope you'll notice, has this great big fence zigzagging down some steps, as if into the water, implying that you are at least a few meters above water level where this picture is taken. So I put the observer at 20 meters, because there's a 10 meter pixel, so I put the observer at 10 to 20 meters above. But you can see in this image that what's reflected in the very far end of the lake is trees. And the reflection of Mount Cook here, or here, whichever one of those two is the real summit, I think it's this one. It's level with this water here, the near side of these reeds. So the water that's providing your reflection of this distant mountain is how far away? How far away would you say these plants are from that viewer? There's sticks sticking out of the ground here. They could be really big plants. Could be, what, 50 meters? It's not 725 though, is it? And going back to the larger image, the stuff being reflected furthest away, the stuff where the angle of the surface of the water is furthest from your eye level. Let me just, oh, it is already zoomed in. Damn, man, it's already zoomed in. Let me guess. Danny Pratt said there was no distortion at all. Does that look like there's no distortion at all there? Does it look like maybe there is just a bit, maybe some stretching, or maybe some ripple effect making a mess of things because it was not quite a perfectly still day? I bet he said it was a perfect reflection with no distortion at all. Wrong as usual, Danny. Wrong as usual.